Hello, I'm Dr. Sarah Bauermeister, Senior Data and Science Manager for Dementia's Platform UK. Welcome to our webinar. Today I'm going to take you through how to identify, access and analyse cohort data on the DPUK Data Portal. The Data Portal is a secure repository for over 3 million participant records across 42 cohorts. These data are never downloaded but reside securely within our platform infrastructure. However, these data are accessible for bona fide researchers across industry and academia after they have identified cohorts of interest and submitted a full project proposal. I'm going to take you through the process today, so at the end of it, you'll be able to apply for your own project using cohort data from DPUK and the Data Portal.
Navigating to the Data Portal website, researchers are able to see all the functions that are required for accessing data on the Data Portal. So here we invite researchers to identify, access, and analyze. And under these tabs, you'll see there is a list of data visualization tools. Under access, there is functions for applying for data access and the application process. And under analyze, we have links for the analyses environment and information on our data linkage. So first of all, identify. So the most important part of any application process for data on the data portal is to be able to identify appropriate cohorts of interest. So if we go into the cohort matrix, we'll see that this is an overview of all data available across our cohorts. So scrolling down here on the left-hand side, we have a list of our cohorts with basic baseline information, such as participant number, start date, age at recruitment, and gender. We also have outlined the data access process, whether direct access is only via the portal or whether an additional application will have to be made to the cohort owner. We also have data availability, whether it's the whole data set, all waves, or perhaps just a selection of the data. If we click on here at data categories, we can see an overview of what data is available within those cohorts. And this is categorized according to our ontology of 22 categories of data. We can see there's everything from administration, socio-demographic, family history, all the way through to psychological status, mental health, and at the end, we have our imaging and genomic data categories. So this gives a very quick overview of which cohorts to focus on for information. But what it doesn't give you is the fine-grained detail that is required for accessing and applying for data on the data portal. So if we go to the cohort directory, we'll see that this is a directory where additional information is provided on each cohort. So if we just click on one here for an example, which is the ELSA study, the English longitudinal study of aging. Again, on the left-hand side, we have our 22 categories of data, and on the right-hand side, we have all the information about the cohort. So we have a study overview, subjects at baseline, whether there are multiple waves collected, follow-up data, how the data was collected, and also the contact details for that cohort as well. So if we go into one of the categories over here on the left-hand side, in this case, we'll go into physical health status, we can see that the researcher is able to see exactly what variables have been collected within that top category. So on the left, we have the subcategories, for example, cardiothoracic. We have an explanation of the variable type, and we can see these type of data have been collected across all waves of ELSA. So this is the cohort directory, which informs researchers for understanding which cohorts are applicable for their research question. Once they've identified the appropriate cohorts, they can then pursue applying for data access. So if we click on over here, we'll see this is our application form. The application form is designed to be relatively straightforward, but nonetheless includes all categories, which you would usually find in perhaps a small grant application form. So over here, we we would like you to fill in your main applicant details, the role on the project, and whether your research could be considered as a further understanding of dementia or neurodegeneration. This is for information for helping us to develop this process even better for our applicants. You have an option to add co-applicants. Here, although you add your co-applicants right at the beginning, you can also add them at a later stage once your project is underway. Clicking on project details, you are able to enter a study name, beginning and start date into a section where we would like to know about how is the study being undertaken for the public interest. We feel this is really important, so we put this at the beginning of our form. Data requested. Over here, you will select the categories that you've already identified through the data visualization tools. And again, the 22 categories will come up over here for you to select from. These are the top level categories. You've already identified the subcategories and variables that you know are within this category. So we don't have a selection for all categories, because we really would like researchers to think about the categories of data which are appropriate for their research question. And then you can just select an additional cohort underneath. So there is no limitation on cohorts to be selected for your research question, but we do request that researchers only select those cohorts which have appropriate data and are appropriate for answering their research question. So if we go now to scientific context, here we ask researchers to fill in a study overview, scientific rationale, an analysis plan, and justify ethical approval, and to show that they've read the data processing terms which are available to click on over here. So we do have a user guide online for completing these sections, but it's approximately 250 to 300 words per section. And then we move on to technical specification. And this is where you decide what type of analyses you're going to be running. So here in this case, we would like to run perhaps a multimodal analysis, in which case we would need a larger desktop. And if we require any additional software which is not available on the data portal, we give researchers chance to insert this over here so we can consider their request. And here we can also provide perhaps additional hardware such as a Linux desktop for those researchers requiring a multimodal analysis. And then we simply click on the verification box and send the application. This will then go for scientific scrutiny at DPUK before being sent out to our cohort owners, where they will then give their permission for accessing the data sets for this project. Now I'm going to take you through how to access your data set on the Dementias Platform UK Data Portal virtual desktop interface. So first of all, once you have had at least one cohort return to you with an approval to access their data, we will set you up with a DPUK user account where you will set up your own password. We will also give you instructions how to download Google Authenticate on your mobile device to generate a verification code. So first of all, if we go into the VMware, which we will also give you instructions how to download onto your computer or your laptop. How we access the dataset is through a two-step authentication process. That will be through your username and password, and also the code which you will generate through your Google Authenticate or another authentication app. So the first screen you'll see after downloading the appropriate VMware will be a connection to the offsite UK SERP. If you double click onto there, you will be presented with some user terms which you have already signed up and agreed to through your data access agreement. So here you will insert your authentication code and your user password. You will see a single desktop visible. Now, this desktop is assigned to you according to the analyses that you proposed in your project when you submitted it through DPUK Data Portal application process. First of all, the default desktop will be a floating desktop. This is 8 GB and is perfectly suitable for most statistical procedures. A 32 GB desktop is also available for those who would like to undertake machine learning and more complex modeling. We also have an extra large desktop available, which is 128 GB, and this desktop is suitable for those people who would like to undertake more computationally intensive machine learning modeling and also structural equation modeling and more intense latent construct procedures. We also have a Linux desktop available for multimodal analyses using genetic and imaging data. So if we go into the extra large desktop, this is a Windows interface, but it will work equally well on a Mac or a Windows device. So first of all statistical packages are pre-installed. We have SAS, Stata, SPSS, R, Python, MATLAB, and we are perfectly willing to discuss any other statistical packages which you might use on a regular basis. So these are all pre-installed for your use. So if we go into the project folder of the computer, you'll see it's much like any other setup that you would have, which is not in a virtual environment. So we have 4 different drives over here. We have a user drive, which every applicant to the data portal will be able to look up their particular name here. And this is where you can do private work, store your scripts, and work outside of perhaps a group which you have been set up with for your project. We also have the projects folder, where you will see a list of all the projects, but you will only be able to access your own project within here. So if you try and go into someone else's project, you will be denied access. So if we go into an example project folder over here, you'll see that all the cohorts which I've been given approval to are listed within this project folder. There are also listed other cohorts which are not available through the DPUK platform, which I've gained permission for to upload these within my project folder. And this also applies for data which you've collected yourself. You're able to upload this in your project folder and no one else can access it except yourself. And this can be removed after the end of your project. It does not belong to DPUK. So if we go into a project folder here, so here I have an ELSA data set, and I will show you the capabilities of the virtual desktop is much the same as a normal desktop that you would have, which is not virtual. So opening up the data set. So here I'm working in Stata. I'm able to process my data, I'm able to recode, clean my data, and do everything all within one single project folder. And this means that you're able to do this alongside your collaborators. So you'll all be working within one project folder. There'll be master data sets that only the PI or whoever's been assigned to look after those data sets will have be able to alter or adjust those master data sets. For everyone else, they'll be able to look at the data sets, take a copy, and move that to their own user folder so that you can conduct work on one side. But equally so, you're able to work within this folder and share code and share analyses. So here you can see on the 128 GB desktop, you're able to conduct more complex analyses such as item response theory analyses, and the desktop, much like a normal desktop, is able to handle these computationally intensive models perfectly well. So here I'm running a structural equation model, which would normally be fairly computationally intensive, and the virtual desktop interface is perfectly suitable to handle this type of model. Likewise, with machine learning models as well, these are able to run on the 128 GB desktop. So here we have a model. It's completed within a similar time to what would be off the virtual desktop interface. and this is just creating a graph here. And you can see this would be exactly the same as if you were working on your desktop. Likewise, if you wanted to do a multimodal analysis, you don't have to move too far. You can just click into your Linux desktop, which you would have also requested for if you're doing a multimodal analysis, so that you would have this alongside and easily accessible to you. So this will either log in on its own, or it will ask me for my username again, but it looks like it is logging in itself. So this desktop, the Linux desktop, we will discuss with you if you need this for your multimodal data. Again, going into the folder structure would be exactly the same as a Windows, where you would see all the project folders from, but you would only have access to your own. So over here, we have some images that we have pre-processed through the data portal. The advantage of working on the DPUK Data Portal is that everything can take place within this single infrastructure. So we're still in the VMware. These images have been pre-processed through the data portal, and we've not had to move onto another computer because the additional storage, we have requested that storage for our image and our genetic data. So if we open this in the terminal, so here I'm opening up my software, which in this case is FSL, and this should open up. So we can pre-install for you any software that you want. So we're using FSL Eyes here, but equally so, if you're using another imaging software that you would like us to pre-install, we will happily do that for you. So if we, and this will work exactly as if you were on your desktop, but this time you're still in the VMware, where on the 128GB you have your statistical modeling. So if over here we select some images, and this will open up into the software, and you will conduct your analyses and your exploration of the image data as if you were not within a virtual interface. So much the same for those of you who do imaging analyses, there would be no difference. So now we would like to use these data and the derived metrics within our model on the other desktop. So if I just think which image we would like, so if we go for hippocampal, and here we have our metrics. We have our participant ID, voxels, and volume. And this derived text will be able to then be copied over into the 128GB desktop, where it can be used in a statistical model. So this is just for a single participant, but you could process batch files for your purpose. So likewise, if you have genetic data, we'll just go back into where we have stored and processed our genetic data. In this case, we have some biobank genetic data, which we are processing on the data portal. And if we just open up this, we have decrypted it for use within a statistical model. And again, you would extract these metrics back to your 128GB desktop, where you would then be able to run your models on multimodal data. So that's really the VMware and the virtual desktop interface of Dementia's Platform UK Data Portal, where you are able to conduct multimodal analyses all within a single virtual desktop environment. Importantly, what you would like to do after completing an analysis is extract outputs such as graphs, figures, and tables for publication and presentation purposes. So if we go back to the 128GB desktop, here we have the figure that we produced earlier on after running our structural equation modeling analyses. So if we just save this figure to, in this case, the desktop or your project folder, Here on the desktop, we'll see a files in and out function. If we double click on this and we enter our username and password, again for security purposes, you'll see a window opens up with 3 different options: request files out, pending requests, and retrieve files in. So here you're able to extract output off of the data portal, and you're also able to load in scripts and data sets which you would like to upload to work with alongside your project on the data portal. So if we double click request files out, just make this window larger, click on drop files, go to the desktop where we've saved our figure, and then we select the project that this is connected to for reference purposes. And then we certify that these outputs comply with the data access agreement which we signed. In other words, we're not attempting to extract output such as data off the data portal. And then we simply send our request. So this request will be scrutinized by our data scientist, who will make sure that this is just output for publication purposes and not an attempt to download data off the data portal. So that is the research pipeline from analyses to extracting the output off of the data portal.